Welcome to this module on no-code applications of large language models. In this module, we'll demonstrate how to create applications leveraging large language models without writing any code. The advancements in this field have been truly groundbreaking. Take for instance recent strides in models like SoundCloud GPT, which are transforming almost every industry. This transformation is further accelerated by the newest generation of large language models. These models don't just respond based on their training data. They also have memory, access to a suite of tools and the internet, and can autonomously perform a range of tasks. A prime example of this new generation is AutoGPT, known for executing intricate tasks autonomously. Another instance can be found in a tool designed to advance the recovery of synthetic molecules. This tool, representing the new generation of large language models, can explain the synthesis of a molecule, detail its derivation mechanism, and identify similar molecules. Users can specify any of these tasks, and the tool autonomously interacts with external platforms through APIs such as STEM-Space or PubChem to gather more information on molecules and their reactions. Employing these tools, the large language model can autonomously perform actions. For example, a model named Crow can formulate a strategy to tackle any of the aforementioned queries. It then engages with the tools at its disposal, collecting further data in the process. Ultimately, it presents a comprehensive response to the user. Impressively, it can do this iteratively, breaking down complex tasks into smaller steps and addressing each to arrive at a final result. This highlights the capabilities of a state-of-the-art large language model. It can access specialized chemical tools to review patterns, discern molecular similarities, and grasp modifications of certain molecules or functional groups. Beyond that, it can tap into general tools for web searches, scientific research, and even those for planning chemical reactions. The key to harnessing such a model lies in the LangChain tool. LangChain has redefined industries by introducing a framework that streamlines the use of large language models, such as OpenAI's GPT-4 or models from Google. With LangChain, we are positioned to achieve breakthroughs in natural language processing and design intelligent applications capable of sophisticated autonomous tasks. An example application could be a virtual agent powered by large language models to communicate with clients, retrieve and store data, and autonomously issue invoices. However, LangChain isn't without its limitations, primarily being its requirement for programming know-how. So, how can individuals without coding skills develop applications with large language models? Flowise. Flowise functions like building blocks, allowing users to integrate various components, be it a PDF loader, OpenAI embeddings, or a Pinecone vector database, and construct a personalized GPT chat that learns from individual documents or without coding. Flowise offers a user-friendly drag-and-drop interface to design custom workflows for large language models using LangChain.js, built on the LangChain library. While Flowise itself is free, users may encounter costs when leveraging proprietary models like those from OpenAI or for storage needs. LangChain.js' standout feature is its intuitive visual interface. It lets users craft applications centered on large language models via a drag-and-drop method, negating the need for coding. Essentially, it offers the power of LangChain.js without the intricacies of Python programming, making it an invaluable asset for those keen on developing cutting-edge large language models but lack the technical expertise. In this task, we will discuss the features of Flowise and the reasons for its recommendation. There are three primary reasons to consider Flowise. Firstly, it is open source. This means we can utilize it for our projects under the Flowise license without incurring additional costs, even for private use. Secondly, Flowise is renowned for its agility in development. It enables the design and development of applications from inception to completion, leveraging this kind of model, and facilitates rapid deployment to production. Lastly, Flowise stands out as a versatile tool for developing language models. We can construct specialized models for integration into our applications. Additionally, it offers a wide array of components and is highly extensible. It pairs well with external tools, ranging from vector databases like Pinecone to expansive language models from OpenAI. One could liken it to Lego, allowing us to piece together the required components for our application seamlessly. The trio of features, being open source, promoting swift development, and providing extensible components, renders Flowise a formidable tool. Moreover, it paves the way for seamless connectivity between various large language models. This enables the programming of multiple models, each tailored for a unique task, and effortlessly linking them. There is also the advantage of prompt templates, which allow us to devise templates with calls to diverse models. This setup facilitates a chain of models, each adept at a specific task, collaboratively executing more intricate functions. Flowise also demystifies the programming of interactions with large language models, akin to traditional questions and answers systems or chatbots. It encompasses components for functions like translation and empowers us to create conversational agents endowed with advanced features such as memory or integration with external tools. All of this is made possible by libraries like LangChain, all without penning a single line of code. Having shed light on Flowise and its salient features and benefits, in subsequent tasks we will delve deeper. We will elucidate how to install it locally and provide guidance on its usage. In this task, we will explain how to install Flowise. To begin, navigate to the official Flowise page and proceed to the GitHub section. Here you will find various installation options for Flowise. One option is through the installation of Node.js, which is among the most straightforward methods. Another method involves using a Docker image with specific commands. Additionally, there is a dedicated installation option tailored for developers. For our purposes, we will opt for the installation via Node.js. To do this, you need to ensure you have a version of Node.js that is 18.15 or higher. Navigate to the relevant link, where you will encounter installation options depending on your operating system, either Windows or Mac. If you are using Windows, select the installer tailored for this OS. You also have the option to install using a zip file. Once you click on the appropriate link, the zip file will begin downloading. From here, simply follow the Node.js installation instructions provided. With Node.js successfully installed, proceed with the commands specified. To do this, open the CMD or system prompt from the Windows search bar. Once opened, copy and paste the provided command into the system prompt, execute it, and after a short while, the installation should conclude. Subsequently, initialize Flowise using the given command. Return to the CMD, paste the command, and upon execution, Flowise will commence its initialization process. Once completed, launch your browser and input the address localhost 3000. This will display Flowise operating in a local environment. Within the Flowise interface, you'll observe an options menu, various chat flows or projects, and a marketplace where you can access Flowise components. This marketplace offers chat flows, which are essentially pre-configured templates complete with components and language models or pre-designed processes. Additionally, there is a separate section dedicated to tools. You will also come across the API key section, which houses your credentials. Upon creating your inaugural chat flow, more options will become available in both the Tools and Credentials section. In this task, we will delve into the initial steps of using Flowise. As previously mentioned, Flowise operates much like a set of Lego pieces, enabling users to assemble various components associated with advanced language models. Among these components is the drawing mode, which includes vector databases, access to a multitude of advanced language models, whether open source or proprietary, and other unique features tied to LangChain. All these components can be found in the Marketplace section. For instance, within this section, users can tap into a range of templates tailored for creating conversational agents. Additionally, access to SQL databases is available, as is the capability to link various prompts. Users have the flexibility to either craft a brand new template or employ one that's already available in the Marketplace. Upon selecting a template from the Marketplace, various sections or components will populate it. Consider, for example, a basic template that integrates a call to the DaVinci model from OpenAI. Since DaVinci is a premium model, this is where users would input their API key. This component interfaces directly with LLMChain. LLMChain then processes a prompt, essentially serving as an instruction or query for the model. For this template, the prompt might revolve around gauging the weather in a designated city, with the city's name being a mutable variable based on user input. With all components inclusive of the API key and the prompt seamlessly linked to LLMChain, this entire template or process can be saved. Subsequently, users can activate it on a designated side panel where the model awaits user prompts. Given that the embedded prompt resolves around weather data for a city, users merely need to specify a city, and in turn, the model furnishes them with current weather details. More intricate flow structures, like the one currently under scrutiny, aren't limited to just invoking the model, in this scenario GPT 3.5 from OpenAI. They also encompass memory functions, access to the SERP API, and an integrated calculation utility. The synthesis of these elements births a conversational agent primed for engaging users, retaining information throughout the dialogues and executing sophisticated calculations. Transitioning back to Flowise, let's architect a basic chat flow. As previously highlighted, there exists a multitude of avenues to achieve this. Users can either start from ground zero or cherry-pick a pre-existing template from the Marketplace. For this exercise, we'll opt for a translation-centric template, specifically the translator one. This template leverages the OpenAI API key to reach the advanced language model and couples this with a prompt template to guide the model's operations. Upon accessing this template, its configuration is laid bare. Users wishing to utilize it can simply select Use Template. The inaugural step revolves around embedding credentials via the OpenAI API key. To procure this key, users need to navigate to the OpenAI platform and instantiate a new API key secret under the API keys user segment. Subsequently, users revert to Flowise, pasting the freshly copied API key. First timers will need to click on Create New, designate a moniker, and submit the key. Post-submission, a confirmation message will materialize, signaling a successful addition. Following this, users can toggle between models, variants such as GPT 3.5, GPT-4, and others. Furthermore, supplementary parameters like temperature, which dictates model creativity, can be fine-tuned. The ensuing step requires configuring the prompt template, which acts as the model's directive. In this scenario, it comes pre-configured to translate inputted text from one linguistic medium to another. Users can recalibrate input and output parameters under prompt values, say transitioning from English to another tongue. Upon completing these configurations, it's pivotal to retain the chat flow by selecting Save Chat Flow and appending an appropriate title. Once all is set and cemented, users can trial the flow with sample text and witness the ensuing translation. Concluding the testing and requisite tweaks, a plethora of integration routes unfurl. This encompasses creating an API endpoint, extracting code from HTML or React embedding, and diversifying chatbot sharing modalities. Within the settings ambit, users hold the power to duplicate, upload, export, or expunge the chat flow as per their discretion.